All right, grade 12s, we are doing our last lesson. There we go. Our last lesson for this unit. I'm going to put days 5 and 6 together, so this will be a long one, but you can watch it over the course of 2 days. So we are revisiting the box problem that we had on your test that you just loved so much, and it's just showing up from time to time. And today and tomorrow we are doing real world problems, somewhat real world, um, that involve volume and geometry. And what else have we got here? Company, business and revenue, and height. So first of all, with the box problem, we have a piece of cardboard that has been cut. So they're cutting out corners that are X by X in order to fold it up and create a lidless box. So we first of all want to look at the formula for volume. Volume is length times width times height. So we have a length which used to be 28, but now that we've cut out 2 little corners, we have 28 minus this length and this length, so it's going to be 28 minus 2x. The width of this thing used to be 21, but since we've subtracted 2 little bits out, throwing pens around, cut 2 little bits out of x and x, then that width is going to be 21 minus 2x. And when you fold the sides up, it's going to have a depth of x for the height. So our volume is going to be 28 minus 2x times the width, which is 21 minus 2x, times the height, which will be x. If we want to know the volume when x equals 3, we can do it in 2 different ways. We can solve it now and expand for x, or we can put a 3 in right now, which is probably the simpler way to do it for this particular problem. So wherever I see an x, I'm going to substitute a 3, and we're going to solve. Okay, so I've got 28 minus 6, which is 22, times 21 minus 6, which is 15, times 3, and we will have our total volume for that box if you cut a 3 centimeter by 3 centimeter square out of the corner and fold it up. So our volume would be 990, and all of the units are centimeters, so it's going to be centimeters cubed for volume. The surface area, oops, the surface area could be done in one of 2 ways as well. You could do the surface area by saying the surface area used to be 21 times 28, and then I cut some stuff out. So you could do the surface area as 21 times 28, and then take away 4 little squares that are all 3 by 3s. And we could get our surface area from that. Let's just do the math on this. It would be 588 minus 4 times 9, which is 36, which would be 552 centimeters squared. We could do it the longer way, which would be the bottom. 21 minus 2x was the width, times the length. 28 minus, I've got to get my numbers straight here. So that's the bottom. And then you have the 2 smaller ends. So you would have plus 21 minus 2x times x, which is the small face, but there were 2 of those. And you would have the other longer sides, which would be 28 minus 2x times x, and there were 2 of those. Try and draw what I've done here. It's hard to draw in 3D, but we have a box with the sides folded up. And so we have the bottom, which is hiding underneath there. We have the two n's that are a little on the smaller side, so there's one there. And there. And that would be the two small n's. And then you have the two larger n's here and here. There. So that formula would get us there as well, and we can substitute a 3 in at this point. 21 minus 2 times 3 times 28 minus 2 times 3 plus 21 minus 2. It's long and complicated, but sometimes rearranging the formula before you substitute can be helpful. This is a times 2. I'm going to sneak that 2 in there. Plus 28 minus 2 times 3 times 3 times 2. So we should get to the same place if we're careful with our arithmetic. So 21 minus 6 is 15 times 28 minus 6 is 22 plus 21 minus 6 is 15 times 3 times 2 is 6. 22 again times 6 is 15 times 22. 330 plus 15 times 15 is 225, but 15 times 16 is 240. And 22 times 6, 132. Put those all together, and you will get 552 centimeters squared again. So whether you simplify first or substitute first, you should get to the same answer. All right. Thinking back for the volume again, we're going to find x if the volume is 990. So we had our volume formula. I'm just going to rewrite it again. Volume in terms of x is 28 minus 2x, 21 minus 2x. Times x. So if we know our volume, we want to find the size of a little square we would need to cut out to get that volume. So I substitute a 990 there, and I am going to tidy up that mess. So I am going to do my FOIL first and deal with my x later. If you don't mind, just because this is what I'm used to, I'm going to put the x at the front, and I'm going to do FOIL with those nasty numbers. 21 times 28 is 588. Outside is minus 56x. Inside is minus 42x. And last is positive 4x squared. I'm going to multiply all of that by x. 990 equals 588x minus, I'm going to put those two together, minus 56 and 42 is 98 minus 98x squared. I just put those guys together, plus 4x cubed, and I've got the 990 on the other side. I'm going to subtract 990 from both sides, and I'm just going to reorder this so it's the cubic like I'm used to seeing it. 4x cubed minus 98x squared plus 588x minus 990. And we want solutions to this problem. This is where we try and factor. This is not nicely factorable for you, but I have some tricks up my sleeve that you don't have, so you don't need to write this down, but I'm going to show you. When I factored this, I had a greatest common factor of 2. And with some things that I know, I could factor it as this times this times x squared, 2x minus 33. We know that volume makes sense to have a cubic, and that we could possibly have 3 solutions to our problem. But with what we have here, we would have the solutions x equals 3, x equals 5, or x equals, I am taking 33 and dividing it by 2, 16.5. Well, this answer doesn't make any sense because we cannot have x equals 16.5 because 21 minus 2x is the width, and that would be 21 take away something that's bigger than 21. So that answer doesn't make any sense. But if you're not able to factor it, we would use a graphing calculator to graph it and find x-intercepts. If you were to do that, you would find the two x-intercepts of 3 and 5. So we can have a volume of 990 if x is either 3 or is equal to 5. To show you what this looks like, I put the function into the calculator. To find those x-intercepts is a fabulous way of solving these problems. I went to the windows because I knew my volume wouldn't fit into the regular screen. So I thought about my x values. I don't really need any negative values, but I wanted to just have enough information to see it clearly. So I started my x values at -2. Can start it at 0 is fine. The maximum size for x is smaller than 20. It would actually be the largest size you could cut out of the corner would be half of 21. So really my x max could be something like 10. So let me just change my graph. My y values are my volume. I know my volume can't actually be negative, but just to see it clearly, I've written that for my y min. And my y max, I didn't know what my maximum volume could be, but I know that 990 is a value that I'm looking at for this problem, so I went with a number much larger than 990. At least my numbers are reasonable, and I'll see what my graph looks like after I've hit the graph button. So I don't have quite enough on my windows here. So I'm going to go back to the 20. So that problem wants to know when is the volume 990. So I want to find the x values when the y value is exactly 990. Kind of a cheater's way to do it is to just trace along and look at your y values and determine when are they close to 990. And that happens, whoops, went past, when x is approximately 5 and the volume is about 990 as I come down this side. Went too far again. When x is approximately 3. We can check that our two values are correct by doing the value function. When x is 3, what is the y value? Exactly 990. And when the x value is 0, and the x value is 5, the function is also exactly 990. If I go back to my y equals button and I add to it minus 990, I have moved that function down 990, and my x-intercepts then would be the solutions to when this volume is 990. In other words, I have set my equation equal to 0 by subtracting 990 from both sides. And my x-intercepts would be the solution to this problem, which would be 3 and 5. So let's have a look. It does look like 3 and 5 are my x-intercepts, which would be my two solutions to this volume problem. But we can get that exactly by looking at zeros. So one of my zeros is this one. I'm aiming for the one that I expect to be 5. So I'm going to the left of it. I am going to the right of it and hitting enter. And there is the exact answer, 5. Is my answer to that equation when I've set it equal to 0. Here's a practical question that people use. A company charters boat tours around the Maitland Island. They can sell 200 tickets at $50 a piece. But for every $10 increase in price, they can sell 5 fewer tickets. Find the maximum revenue. So should they increase their price? Should they not? When can they make the most money? So to find revenue, I start from what happened at the beginning. At the beginning, they sold 200 tickets at $50 a piece. So at the beginning, they made $10,000. Okay. But what happened was they decided to up the price but lower the number of tickets and hopefully make more money. So I am going to let X represent the number of increases they should impose, I guess. So the increases I'm talking about would be a $10 increase. So what's going to happen to the revenue is that 200 tickets is going to go down. They used to be able to sell 200 tickets, but every time they increase the price by $10, they sell 5 less. So they're going to sell 5 less times the number of increases they decide to impose. So that's the new number of tickets they can sell. The new price will be $50, but we've increased the price X times. So maybe we'll increase the price once, and our tickets are now $60, but we will only sell 195 tickets. So that's where we get that equation from. We want to maximize that revenue. If we're looking for a maximum, we're looking for a vertex. And we want to know where that vertex is. So I am looking at this function, and the way I would like to do it is to factor it. Well, it's already in factored form, but not in the best factored form. So I'm going to take my equation, because I notice in both brackets there's a greatest common factor. So for the first bracket, there is a factor of 5. And that makes that a little bit clearer. For the second bracket, there's a factor of 10. So I'm going to factor out a 10, and I'm just going to put that at the beginning with the 5. So this is factoring. Factored out a 10. There we go. Best case scenario in factored form. This will allow me to say that my x-intercepts are 40 and -5. So that means I have a parabola I know it's upside down because I'm looking for a maximum. I also know that if I were to expand that, there, let me just draw this first. If I were to expand this equation, I would end up with, when I do my last terms, negative 50x squared. That is the leading coefficient, and it is negative. And that tells me that my even degree function is opening downwards. So I would like to know what this vertex is. And I have it in the form that easily gives me the x-intercepts. We can go from here. If we know the two x-intercepts, we can find the vertex. The vertex will give me my maximum value, and I can find that by looking in the middle of the two x-intercepts. So if I have an x-intercept at -5 and one at 40, the middle is 17.5. Now how on earth did I get that? I am going to average the x-intercepts. So the x value of my vertex, which we called the axis of symmetry in grade 10, is when I take my two x-intercepts and average them. Add them together and divide by 2, and you will get 17.5. But that's not quite our answer. That tells me when the answer happens. But if I want my maximum revenue, I want a point. And I know that point is going to be 17.5 something. And to get that y value, I am going to substitute x equals 17.5 into the function. It doesn't matter where. If you want to substitute here, or if you want to substitute here, or if you want to expand and substitute, it doesn't matter. You will get the same answer. So let's substitute 17.5. I'm going to do it in the first form, which was 200 minus 5x. Times old price was $50, and we're going to go up by $10. 17.5 times. All right, 200 minus 5. It's 112.5 times 50 plus 10 times 17.5 is 175 plus 50, 225. So the maximum revenue will be that times 225, which is $25,312.50. Who knew? All right, that is the number that goes right there, which I can't fit. The question asked us, how many increases do we need? Find the maximum revenue. So the maximum revenue is $25,312.50 when they sell the tickets for, we have an x value of 17.5, which means they increase the price by 17.5 $10 increases, which means they increase the price by $175. So they have increased the price to $225. 17.5 $10 increases to a $50 ticket. Number 3, a height problem. Jude is diving from a cliff into the ocean. His height above sea level in meters is represented by the function h of t equals -5 t minus 1 squared plus 25, where t is measured in seconds. The maximum height, what do we know about this? The maximum height is 25 meters. And that happens after 1 second. So he is jumping off of the cliff, and this is the maximum. It happens in 1 second. It is a height of 25. I know that because it's in vertex form. I'm going to write it in a different form. I'm going to take my function and I'm going to expand it. So I need to FOIL that t minus 1. I've got two t minus 1s. Be careful with this. And I'm going to FOIL. I'm going to leave my negative 5 for a moment. So first outside, inside, last. T squared outside, inside is minus 2t plus 1. Doing distributive law with that minus 5, I still use arrows and I'm old. Let's do that. Minus 5t squared plus 10t minus 5 plus 25, almost done, equals minus 5t squared plus 10t plus 20. So when we can expand and have that in a different form, we know that the initial height of the cliff, which is your y-intercept, is 20 meters, which makes sense on our graph. We want to know when he hits the water. On the graph, I am looking for x-intercept. I'm looking for this point when he hits the water. There may be another x-intercept over here, but that doesn't make sense to have time negative, so I'm looking for the x-intercept that's positive. So we can factor, or we can use quadratic formula. So let's start with our function. I'm going to factor, I'm just looking from here. I'm going to factor out a minus 5, minus 2t, minus 4. And that is not nicely factorable. We could try, but from here we need to use the quadratic formula. To use an x-intercept, I've set it equal to 0. And that means that either minus 5 is equal to 0, which never happens, or this bracket is equal to 0. And for that, I can use the quadratic formula. T is equal to negative b, which makes it a positive 2, plus or minus the square root of b squared, which becomes a 4, minus 4 times invisible 1 times minus 4, divided by 2. Using the quadratic formula, I will get the first answer will be 3.2. When I use the negative, I get an answer of negative 1.24, and that fits with the graph that we drew, but we know that the negative answer is not applicable in this particular scenario because time isn't negative in this problem. So he hits the water at 3.2 seconds. When is the function negative? And what does that mean? So not time, but the function itself. The function is negative after 3.2 seconds. And that just means that he's gone under the water. The height is less than 0. I noticed it's example 5. I decided to skip example 4 because it was really difficult and not particularly helpful, I don't think, today. So we're going to finish off here with example 5 about a can. This is a reasonable size can this time. For a closed cylinder, find the volume and surface area if the radius is 3 and the height is 8. So we just need to find the formulas for those. Volume equals pi r squared h. And the surface area is 2 circles. And the rectangle, if it were cut open, would be circumference times the height. There we have it. We want to find both of those things if the radius is 3. So my volume would be pi times 3 squared times 8, which would be pi times 9 times 8, which is 72. And I really like it if we leave it as an exact answer. It's 72 pi centimeters cubed. The surface area is a little more involved, but we have a 3 and we have an 8. It would be 2 pi times 3 squared plus 2 pi times 3 times 8. So we would have 2 times 9 times pi, just changing the order a little, and 2 times 24, which is 48, times pi, 18 and 48, 66 pi. Units would be centimeters squared. And that's an exact answer. May not be as meaningful in centimeters to you, but it is a great answer. Find the radius, however. If the height is 7 and the volume is 500, the surface area is 250. So if my volume is 500 pi, and I want the radius times 7. So I have substituted the numbers in where they belong, and I am going to solve for the missing piece. I'm going to divide both sides by pi and by 7. So 500 divided by 7 pi would be my radius squared. And my radius would be the positive square root of 500 divided by 7 pi. That gives me an answer of approximately 22.7. I like this second last answer better because it's an exact answer. For part B, we've asked if the surface area is 250, find the radius. So I need to put my 250 there, and 2 pi r squared, 2 pi rh. There we are, and I want to solve for r. So I'm going to divide both sides by 2 pi. Actually, I'm not. I'm going to subtract 250 from both sides. So I'm going to have an equation equals 0. 2 pi r squared plus 2 pi r times 7 would be 14 pi r minus 250. So I just rearranged it a tiny little bit. Notice that I have a number, an ugly one granted, but a number in front of r squared plus a number in front of r, take away a number. This is a quadratic in the form a r squared plus b r take away c. I can use the quadratic formula to solve that. I could get two possible answers for r. All right, my r can be negative b, which is negative 14 pi, plus or minus the square root of 14 pi squared minus 4 times 2 pi times c, which is, negative 250. All over 2 times a, which is 2 times 2 pi. This is as ugly as sin, but let's see if we can go a little further. Minus 14 pi plus or minus the square root of 14 squared. Oops. 14 squared, I should know that, is 196 pi squared. Minus, actually, we take away a negative number would be the same as adding. 4 times 250 is 1,000 times 2 is 2,000 pi over 4 pi. I'm going to type that all into my calculator and I'm going to come up with 2 approximate answers. After I typed those nasty equations in and all the smoke cleared, I got 2 answers of approximately 3.71 for a radius or negative 10.71. We know that a negative radius just doesn't make sense, so we can disregard that answer and go with the positive radius of approximately 3.71 centimeters. There are so many questions to do and so little time. Make use of your next 2 days. Page 126, 1 to 14 are great, and I have 2 handouts that I would be more than happy to give you, and I have solutions for those as well. You can be totally prepared for any coming tests.